experiments, typically, okay? I'm not saying that string theory is wrong. It's just very impossible to test it experimentally because of its too many dimensions, okay? Extra dimensions. Maybe I should not say too many dimensions. 10 or 11. So there is that. Anyways, basically he's saying that supersymmetry is to be expected because supersymmetry was a thing even in other things, not just in string theory. So once again, and since at the time quantum field theory was the central rage of the mainstream particle physics community, with string theory increasingly becoming a subject on the fringe, it's still kind of a subject on the fringe. The insights of West and Zumino launched a tremendous amount of subsequent research on what has come to be called supersymmetric quantum field theory. The supersymmetric standard model discussed in the preceding section, so the part where we say that all the particles of the standard model or all the particles in particle physics have a supersymmetry superparticle partner or a super partner or a SUSY partner, that part is one of the crowning theoretical achievements of these pursuits. We now see that through historical twists and turns, even this point particle theory owes a great debt to string theory. Okay, Brian, with the resurgence of superstring theory in the mid-1980s, supersymmetry has re-emerged in the context of its original discovery. And in this framework, the case for supersymmetry goes well beyond that presented in the preceding section. So now supersymmetry is very much more than just the arguments we made just now until now, with beauty being at the center of it. String theory is the only way we know of to merge general relativity and quantum mechanics. What did I tell you? What did I say? What did I say? What did I say before we started this section? That this is all about grand unification of the two quarreling parts of physics, namely general relativity on the one side, quantum mechanics on the other. The two are like Romeo and Juliet families who don't get along, but they have a love-hate relationship between them. Something has to come in and grand unify them, and string theory is the candidate for that. So he's saying that string theory is saved by who? Supersymmetry. Supersymmetry is needed by who? Many, many people, even the particle physicists. So supersymmetry is totally like, even though we haven't found super partner particles yet, he's saying supersymmetry, I'm going to use it. I'm going to use it to prove out string theory. And string theory is needed by who? Unification of quantum mechanics and general relativity. It is still a theory, though, because it's not experimentally proven, okay? But it's only the supersymmetric version of string theory that avoids the pernicious tachyon problem, and that has fermionic vibrational patterns that can account for the matter particles constituting the world around us. So again, once again, hear it with your ears cleared. It's only the supersymmetric version of string theory that avoids the pernicious tachyon problem, and that has fermionic vibrational patterns that can account for the matter particles constituting the world around us. Thank goodness that string theory thought to account for fermions, which are the matter particles in the world around us. If otherwise, we would feel quite excluded. If you cannot account for fermions, you would be sort of a laughing stock, unless, of course, you admitted that your theory is incomplete, which is totally fine. Anyways, so superstring theory does account for it. But how does it account for it? Because of supersymmetry. That's why supersymmetry is in the name of superstring theory. In short, supersymmetric string theory, superstring theory. So SUSY, supersymmetry, very much needed, okay? So SUSY better be real. Scooby-Dooby-Doo, Susie-Dooby-Doo, where are you? In the Large Hadron Collider, we will find you, hopefully. Super partner particles, because if we don't and we never prove that out, then string theory will very much